For many people, the idea of learning how to write computer programs is overwhelming. There are many computer languages, including but not limited to C, Java, C++, C#, BASIC, PHP, Python, JavaScript, SQL, Perl, Ruby, and Visual Basic. Each of these languages has their own complex set of rules and syntax that need to be mastered before anything substantial can be created. For those who've had no exposure to the world of computer programming, the complexity and perceived difficulty of learning the ins and outs of a computer programming language acts as a significant barrier.
As technology has rapidly evolved and become an ever-increasing part of our daily lives, the need for skilled computer programmers has grown exponentially. Over the past 4 decades, many things have been done to increase the general interest in computer science. One of these things has been the development of microworlds for computer programming. Seymour Papert, the father of microworlds for programming, has defined them as a deliberately simplified computational environment that allows students to explore ideas that are not normally demonstratable in an average classroom setting. In the 1970s, Papert and others at MIT developed Logo, a computer program aimed at introducing children to computer science by making programming physical. Originally in Logo, students would write a simple program on a computer that would feed instructions to a robot. This robot would move according to the instructions programmed by the students. In the late 1970s and early 80s, this turtle robot became a turtle icon that would follow the steps laid out by the student programmers on a computer screen. Logo was very popular, and was the foundation upon which many other microworlds were developed. Dr. Ivan Tomac stated there are 2 underlying principles behind the use and development of microworlds for computer programming. The first principle is hiding the richness of the full environment so as not to distract the beginner with too many details, tools, and techniques, and to make learning easier. The second is creating an environment which presents the students with more interesting tasks than the commercial programming languages. This idea of making it both easier and more interesting to learn computer programming is clearly seen in this year's Google Santa Tracker website. One of the daily activities for children to play with was a microworld for computer programming. It had children learning very basic concepts of programming in a simple drag-and-drop format. It followed what is a typical format for many current microworlds: block programming.
In block programming, as seen here in Scratch, an object is selected to program. Various blocks can be selected and connected to give the object a set of instructions for how it can be controlled, react, or interact with other objects within the program. This is a very simple and intuitive way to learn to program. Those using microworlds to learn the basics of computer programming quickly come to understand basic logic such as if-then statements. The programs that can be created in microworlds range from very simple to exceedingly complex. They provide students with an opportunity to really stretch their learning. Though the specific ins and outs between various microworlds for computer programming may vary, they all typically follow the 4 pillars of microworlds, which are metaphors, visualizations, constructivism, and games. Programming microworlds are built on metaphors, in that they connect very intangible ideas and concepts with the real world. Programming microworlds are built within a design that explicitly visualizes the fundamental concepts of programming in a realistic and meaningful way. These programs allow students to see very clearly the connection between their programming and the object being programmed. Microworlds are based on the constructivist learning theory. They allow students to build their own learning through a series of trial and error experiences. And finally, microworlds incorporate game-like elements. This ties back to Tomac's principle that microworlds should create an environment which presents the student with more interesting tasks than commercial programming languages. There are all sorts of examples of microworlds for computer programming, and though they all differ in their specific aim, they are united in overall purpose and practice. For microworlds are cognitive learning tools that are used to promote abstract concept understanding. They're small, interactive, and contain programmable models of real-world environments. They are engaging and appealing for students learning. By using microworlds for computer programming, your students won't respond like this, Ugh, boring.
but like this.
Yay, I'm so excited, I love computer programming!